Good morning, everybody. My name is Matt Corniss. I'm a biologist with the U.S. Fish and Wildlife Service based in Green Bay, Wisconsin, and today I'll be sharing updates from the Great Lakes Mass Marking Program. Thank you very much for inviting me to share this recorded presentation. I am sorry I can't be there in person, but thank you all for turning out. Today I'm going to touch briefly on an overview of our program and then provide results from our studies on Chinook salmon, lake trout, and steelhead. Great Lakes Fish Tagging and Recovery Program, which is informally known as the Great Lakes Mass Marking Program, began in 2010 as a multi-agency collaboration to evaluate survival and movement of hatchery fish, natural reproduction, and other metrics for salmon and trout. This was developed in response to a Council of Lake Committee's request, and the main objectives of this program are to evaluate the stocking efficacy of federal and state hatchery stocking programs, as well as evaluate progress towards lake trout rehabilitation. We also seek to estimate the wild recruitment of Pacific salmon that are important to Great Lakes sport fisheries to balance predators with prey. We are funded by the Great Lakes Restoration Initiative through the Environmental Protection Agency, and thanks to your support, we have 12 years of data on over 172,000 fish from open water angling, which gives us a powerful data set to use to address these questions of management importance. The four major prongs of our program include the tagging and marking of hatchery fish, for which we tag and mark about 10 million every year using the autofish trailers pictured here. We also coordinate a large-scale field effort to get data on these fish as they return as adults to the sport fishery, where we sample anywhere from 12 to 17,000 fish every year. Third, we do extract tags not only from our survey, but from our management partners with state and tribal agencies. So far, we've extracted over 157,000 of these coded wire tags. We also age wild fish with about 3,500 samples every year from steelhead, Chinook salmon, and lake trout. And lastly, we provide data analysis and support for fisheries managers. We have marked and tagged lake trout since 2010, Chinook salmon since 2011, and steelhead since 2017, and are adding coho salmon this year to the mix. Some people might be curious to know how these fish are marked and tagged, so I am going to play a brief video here showing this. Now, what we see here are some salmon that are traveling up this pipe into a holding area. This functions off of the fact that salmon like to swim upstream, so they're swimming up here on their own. They're then going to go through this length sorter. You'll see them being passed over these red lights that are taking very rapid lengths of these fish and then sorting them. All that clicking you hear is them being sorted by their size, as each of these 6 tagging lines that you see here is calibrated to a very tight size range of fish. You can see some of the fish flying through here. And in each tagging line, they enter another holding pen, and then they use volitional entry, meaning that they swim upstream into this little chamber here. And here you can see this brown device coming down. That is taking a fin clip, while the fish also receives a coated wire tag in its snout. These are constantly monitored, and there's quality assurance devices with each of these tagging lines to make sure that the fish are clipped and tagged, and if they are not, they are rejected out to a holding net where they're going to be reevaluated and clipped and or tagged by hand. Future plans for our program: I want to note that 2024 was the final year of steelhead tagging. We will still be collecting these fish from the field for many years to come, but the funds used to tag steelhead are now being used to tag coho salmon at the request of the states. The coho salmon tagging is underway, and we have staff who are tagging these fish right now at state hatcheries throughout the states. I want to note that we are also planning to have a tag and data recovery field season in 2025. The extent of that is currently unknown as we deal with some uncertainty with our staffing levels, but we are planning to be out there, and we'll be collecting some fish from 2025 as well to keep progress towards our study objectives. All right, next I'm going to move along to our study results on Chinook salmon. One of the primary things we do for Chinook salmon is estimate their wild recruitment. We do this annually for each year class by estimating wild production from fish returning at age 2. This is when we feel we have the highest confidence in these estimates. Basically, we look at the percent of wild Chinook salmon at age 2 in the system, and then use that with the known number of stocked fish to estimate wild smolt production. I do want to add here as well that we do check the fish coming out of those trailers every 1 to 2 hours at the hatcheries, and based on data on over 100,000 Chinook salmon at these hatcheries, we know that 99.5% of them are coming out of the hatchery with a successful fin clip. So this figure shows the estimated number of Chinook salmon smolts on the y-axis in millions and the year class on the x-axis. The known number of stocked smolts is in orange. The estimated number of wild smolts is in blue. And you'll see some slightly different coloration for the 2020 year class. That's because we did not tag or clip fish that year because of COVID-19. So that's actually an estimate based on the average values of surrounding year classes. And then you'll also see slightly different coloration for the most recent 2023 year class. That's because that's estimated from age 1 fish, and that will be updated next year when we have data on these fish at age 2. So for our last 2 year classes, we have for 2022, a little over 7 million wild fish and a little over 10 million total. And then for this latest year class, we're projecting about 9 million wild fish and close to 13 million in total. Now, if we take out the stock smolts and focus only on the wild smolts, I do want to point out some trends we see in Chinook salmon wild production. First, from the 2006 through 2012 year classes, we had between 6 and 8 million wild fish each year, based on our estimates, which is relatively stable for natural year class production. But then we kind of went off a cliff here in 2013. We believe that this week year class was a result of severe drought during the fall spawning runs that resulted in historic low observations of mature salmon sewing up at the spawning weirs. And this was also followed by a really harsh winter and delayed spring that might have affected early life stage food resources for these smolts. So regardless, after the 2013 year class, which was the lowest we have in the time series, we had several years where wild production was recovering, only 3 to 5 million fish each year. And this is likely because of that weak year class. We had fewer fish turning up to spawn in subsequent years as well. And then as we move back to the most recent 5 year classes, we're back in that 6 to 9 million wild range that we were at earlier in the time series. Now, our data does suggest that northeastern Lake Michigan is a focal point for wild Chinook salmon production. This is based on the knowledge that salmon return to their natal streams to spawn. What you're seeing here on the left is a heat map showing the catch per effort data of our Chinook salmon observations in the fall. And you can see the warmest colors are in northeastern Lake Michigan, suggesting that these wild fish are returning primarily to that area to spawn, which in turn suggests that that is, in fact, where those fish came from in the first place. We were also able to estimate the relative survival of stocked Chinook salmon from different stocking areas in Lake Michigan based on their return rates to the open water fishery. This map is showing a heat map where warmer colors indicate more survival, and we are hoping to have these results submitted to the North American Journal of Fisheries Management sometime in the near future. To summarize, we saw high relative survival for fish stocked along the Wisconsin shoreline. We don't know exactly why this is, but we speculate it may be due to cooler water temperatures or greater abundance of invertebrate forage for these smolts before they turn over to full piscivory. We did see pretty low survival in Green Bay, which we think may be due to warmer water temperatures or predation levels, and fairly low survival in MM6, which we think may be due to competition with wild smolts. All of the potential drivers are speculative, but that is why we think we see these patterns. We also observed relative survival decrease from the 2011 through 2016 year classes that correlated with a declining trend in alewife abundance over this time period. We know from the PPR model that this has rebounded somewhat in the last few years, but we weren't able to track Chinook salmon survival after 2016 because we were no longer coated wire tagging them. All right, next I want to spend some time talking about our results on lake trout. Now, we monitor the catch per effort of wild and hatchery lake trout in 3 major areas: Lake Huron, Northern Lake Michigan, and Southern Lake Michigan. We do estimate these values from the constituent statistical districts in each of these major regions, and we interpret these data as a measure of relative abundance in the sport fishery. These figures will be similar in the sense that the black lines will represent the total lake trout, the gray lines wild lake trout, and the orange line hatchery lake trout. And you're going to look at figures showing relative abundance on the y-axis compared to the sampling year on the x-axis. So here for Lake Huron, what we see is a upward trend here in the relative abundance of wild lake trout in gray, and we can see a relatively flat line here for hatchery lake trout. As a result of that, the total lake trout line for Lake Huron is closely mirroring that of wild lake trout. Moving to northern Lake Michigan, we see a bit of an opposite pattern here. In this case, the gray wild lake trout line is relatively flat. It was actually pretty close to zero from 2013 through 2018, and only recently have we started to see some wild fish in the sport fishery here, primarily in Grand Traverse Bay. As a result of this, the total lake trout line in black is very closely mirroring that of the hatchery lake trout line in orange. Next, if we move down to southern Lake Michigan, we have this interesting pattern where we see that the trends for hatchery lake trout and wild lake trout are opposite to one another. I do want to point out that this is sport fishery data, so this does not include fish from the Southern Refuge. If we look at these two lines independently, first the orange hatchery lake trout line, we'll see this decline from 2016 through to 2024, and that mirrors stocking cuts in this area of the lake from the 2010 through 2018 year classes. That's pretty much driving the decline in hatchery lake trout, while at the same time we are seeing a slow but steady rise in the abundance of wild lake trout in this area, based on recruitment that we believe is occurring at and around Julian's Reef and elsewhere in the southern part of the basin. So for the early part of this time series, we see the total lake trout line in black is closely mirroring the hatchery lake trout, but after 2020, it's starting to more closely mirror the wild lake trout pattern. Now, one value that we used to report that we don't really report anymore is the percent of wild lake trout, and that's because this value was historically interpreted as indicative of progress towards wild lake trout rehabilitation in the lake. But because it's a percentage, it actually is reflecting both the wild and hatchery lake trout trends, as you can see here in this figure, where we have our hatchery lake trout in orange and our wild lake trout in gray in terms of the catch per effort, and this pink line showing the percent of wild fish. You can see that because of the hatchery lake trout declines, the percent wild is actually a much steeper slope than the actual increase in the relative abundance of wild fish in southern Lake Michigan. I also want to take the time to comment on some general trends we've seen with lake trout over the years. This map is showing lake trout stocked in the northern refuge in blue and on the southern refuge in red, with circle size proportional to the catch per effort within the spring LWOP survey. What we've learned from this is that the offshore refuges are providing a source population for nearshore fisheries. We can see between the northern and southern refuge that we have pretty much lake-wide coverage in terms of contributions to nearshore fisheries throughout the lake. But we also see the largest circles are still occurring within those refuges, and that tells us that a portion of lake trout stocked in these refuges are remaining there and receiving protection from harvest, something that we're continuing to study with the acoustic telemetry study currently going on in the northern refuge. Lastly, we have looked at survival for lake trout, and we have seen that the highest survival occurs at Julian's Reef here, with the second highest survival rates on the southern refuge. So we do see higher survival rates from these offshore stocking sites. Also noted some interesting patterns in the relative survival of different lake trout genetic strains. Seneca Lake strain, which is shown here in red, has been stocked in Lake Michigan for years, in part because of their long history coexisting with sea lamprey and because they're thought to have a lower encounter rate with sea lamprey compared to the Lewis Lake strain, which is of Lake Michigan origin. From the 1985 through 1992 year classes, when sea lamprey abundance was higher in Lake Michigan, we saw a higher return rate of Seneca Lake compared to Lewis Lake strain. But in more recent year classes, here between the 2010 and 2015 year classes, we observed no difference in return rate of these two strains, and we attribute this to lower sea lamprey abundance throughout the lake. So this shows that the survival of these lake trout genetic strains may be mediated by sea lamprey abundance. Now, last but certainly not least, I want to move on to our results from steelhead. We are able to estimate the wild production of steelhead using the same methods we use for Chinook salmon. The overall percent wild values in Lake Michigan have ranged from 32 to 50% over the 2017 through 2023 year classes, and this range is consistent with otolith microchemistry results that classified about 40% of observations as wild fish. So it builds some confidence in here that we're getting very comparable numbers from two different approaches to steelhead wild production. So here we have a figure showing the number of smolts in millions for steelhead in Lake Michigan. Again, the stocked smolts are in orange and the wild smolts are in blue. And we do see two major periods that have unfolded so far in the data. For the 2017 through 2019 year classes, we saw about 1.5 to 2 million wild fish produced. Then in the 2020 year class, you'll note a much lower number of stocked smolts, and this was reflected by the fact that there was no egg take in Michigan, and therefore no steelhead stocked in Michigan waters of Lake Michigan, aside from Skamanias that they received from Indiana during the 2020 year class. If we look at the subsequent year classes, we actually see that the number of stocked fish was increased, but the number of wild smolts has actually languished and has been between 0.7 to 1 million wild for these past 3 year classes. We've also been able to look at steelhead movement, and they are very much mixed in the lake, much like Chinook salmon. Where a steelhead is stocked really doesn't have much to do where it's caught outside of spawning runs. And as an example of that, I have a map here showing steelhead that were stocked in Indiana with these pink circles proportional in size to the catch per effort of those fish that were stocked in Indiana. You can see those fish are turning up lake wide. One thing we did note is that there was less movement between lakes for steelhead. We estimate about 25% of steelhead stocked in Lake Huron as being recovered in Lake Michigan. This compares to about 95% of Chinook salmon. And we think the main difference here is that steelhead actually forage on invertebrates and other prey items more readily when alewife is in low abundance. So the big take-home message here for sport fishers is that everybody is catching everybody's steelhead. These pie charts on the left are showing steelhead caught in Illinois, Indiana, Michigan, and Wisconsin. The purple chunks are steelhead that were stocked in Indiana. The blue chunks are steelhead stocked in Michigan. The gray chunks are stocked in Wisconsin. The green chunks stocked in Illinois. And the orange chunks were stocked in Lake Huron. If we compare this to the stocking levels in Lake Michigan, we do see that the catch levels in each jurisdiction is fairly similar to what you'd expect from stocking, with the exception that Indiana stocked fish do seem to be overrepresented in the catch, likely due to higher survival rates for fish stocked there. So we did evaluate steelhead survival, much like we've done for Chinook salmon and lake trout. In these figures, you're going to see on the y-axis, relative survival has actually been standardized to the mean. In this case, a value of 0 represents average survival. Positive numbers are above average and negative numbers are below average. The first thing we looked at, as you can see here, is comparing the life stages. Steelhead are stocked as fingerlings and yearlings, but we have observed an average relative survival rate for yearlings that is 2.5 times greater than that for fingerlings. To put this another way, fingerlings represent about 23% of the steelhead stocked in the lake, but only comprise about 7% of the sport harvest. So because of this, I'm going to focus on patterns in the relative survival of steelhead stocked as yearlings for the rest of this. This map on the left shows fish with high survival in blue, average survival in yellow, and poor survival in red. So we do see relatively high survival for fish stocked in Indiana, in MM7, and in northern Lake Michigan, with relatively low survival in Green Bay, very similar to Chinook salmon, and low survival in WM4. I should note we also had pretty high survival in the Wisconsin small tributaries. This was a tag lot that spanned the entire Wisconsin coastline in small tributaries throughout. And just for comparison's sake, this map on the right is showing the stocking numbers as proportional circles. Although stocking location had a statistically significant effect on steelhead survival, genetic strain did not. However, if we compare survival rates of genetic strains stocked at the same location, we do see a trend here where Skamania had a little bit better performance than Michigan winter strain for fish stocked in 2 of these 3 regions where both of these strains are stocked together. Again, not statistically significant, but something to keep an eye on as we expect to get more data in the coming years. Next, we have a figure showing relative survival of Chambers Creek and Ganaraska strain steelhead stocked in 4 different locations together, and we didn't see any consistent differences in survival between these 2 strains at any of these locations. We also didn't see any consistent differences between Arlee, Chambers Creek, Ganaraska, and Skamania that were stocked in these 2 different locations together. So to summarize for steelhead, we see that all states are depending on one another's steelhead for their angler catch. We see really poor survival in Green Bay and somewhat poor survival in WM4, really good survival in Indiana, NM7 and Wisconsin small tributaries, with no significant differences detected among strains, although the Scamania is trending higher than Michigan winter strain in some districts. Data on age 2 through 4 fish will continue to be recovered through 2028. With that, I'd like to thank you very much for your attention. I'm obviously not here to take questions, but if you do have some, please reach out to me. You can reach me here at this email address. I certainly would appreciate hearing from you. Thank you very much.